Hello friends. So this is another video in which I will be solving previous year KTU problems. So I am solving problems from MOS Civil Engineering S3 subject. This particular problem is from module 5, the MOS. In module 5, this is from the torsion topic. Okay. So this was asked in 2017 January for 20 marks. So it's a pretty straightforward problem, but it is slightly lengthy. Okay, there are one or two problems that you formulas that you have to remember in order to solve this problem very fast. So the problem reads like this: select a suitable diameter of a solid shaft of circular section to transmit 112.5 kilowatt of power at 200 rpm. If the allowable shear stress is 75 MPa and the allowable twist is 1 degree in length of 3 meters, consider GS 0.82 into 10 raised to 5. Okay, so here we have to find the diameter of a circular shaft. We have to find the diameter. What is the diameter? Such that there are two conditions. The shear max should not be more than 75 MPa. Okay, and the second condition is the angle of twist, theta, should not be more than 1 degree for 3 meter length. Okay, so these two conditions must be satisfied. Also, it has to transmit a power of 112.5 kilowatt at 200 rpm. So it has to transmit 112.5 kilowatt at 200 rpm. Okay, so these are the this is the basically the question in a nutshell. Okay, so basically we have two formulas that you should remember. That two formulas, if you remember, this is the only two formulas in torsion that you have to remember. So the first formula is the relation between power and torque. Okay, so this power is given by the basic definition of power is torque into angular velocity. Okay, this is nothing but force into velocity in the linear terms. Here it is torque into angular velocity. So this is nothing but torque into 2 pi f. F is the number of cycles per second. So here number of rotations per second is f. So number of rotations per minute is given. So it is nothing but t into 2 pi number of rotations per minute upon 60 to make it number of rotations per second. Okay. So the formula for power is nothing but 2 pi n t upon 60. So always remember this thing that this power will be in watts, t will be in Newton meter. Okay, so these are the standard units that you have to keep in mind. So this is the first equation. The second equation that you have to remember is the torsion equation, that is T by J equal to tau max upon R. This is equal to G theta upon L. Okay, so this is the second equation that is required to solve this problem. Okay, so now let us list out what all is known here. So known quantities are, or given quantities are, RPM is given 200, then power is given 112.5 kilowatt, power is given, then maximum shear stress is given, that is 75 MPa, and theta is given as 1 degree for length equal to 3 meters. Okay, so now you can see most of the things are given. Now G is also given. What is the value of G? Torsion rigidity for modulus of rigidity is torsion rigidity, modulus of rigidity 0.82 times 10 to the power 5 Newton per mm square, that is MPa. Okay, so all the quantities that we record is given. So first we will use the first equation to find the torsion. Okay, so we know that from power, this equation we can rearrange the equation as T equal to P times 60 upon 2 pi n. So this is nothing but, so this is in kilowatt. The power is given in kilowatt. You have to convert into watt. So 112.5 into 1000 watts into 60 divided by 2 into 5 times n. What is n? N is given as 200 ampere. Okay, so we'll calculate this. If you calculate this, let us calculate this. So it will come out as 112.5 times 1000 times 60 divided by 2 times 5 times 200. So this comes out to be 5371.5. 5371.5 Newton meter. Okay, 5371.5 Newton meter. Okay, so this is done. Now let's find the value of diameter. Okay, so now we have to use the second part of the equation, or the second equation. So let's say so torsion is known in this equation. J we have to find. What is the formula for J? For a circular shaft, solid circle, the J is pi by 64 into e to the power 4. So that is the formula for J. This students are expected to recollect. R is the diameter by 2. This we all know. Okay, so first what we'll do, we'll consider the first two portions of the equation. Okay, so let's say T by, I am rearranging the terms, T by tau max is equal to J by R. This is also, so this means T by tau max equal to pi by not 64. I am really sorry, I made a stupid mistake here. Is pi by 32. Pi by 32. So this is pi by 32 d raised to 4. 1 by r is nothing but d by 2. 2 by d. 2 by d. Okay, so this gives me T upon tau max is equal to pi d cube upon 60. Okay, so from this this equation, this is simplified form of this first two part of the torsion equation. Torsion is known, tau max is known, only d cube is unknown. So we can find d cube. Okay, so d cube will be 16 times t divided by tau max times pi. So this is nothing but 16 into, now here you have to remember that the torsion here is Newton meter. So this Newton meter you have to convert to Newton millimeter. So 5371.5 into 1000 Newton millimeter. So in this formula, this should be in Newton millimeter. This should be in millimeter raised to 4. This should be in Newton per mm square. This should be in millimeter. G should be in MPa or Newton per mm square. Theta should be in radians. L should be in millimeter. Okay, so all these units should be kept in mind. Right, 16 into 5371.5 times 1000 divided by tau max is given as 75 ampere. So this, I don't know how it is, 75 ampere. 75 times. Okay, so now we'll calculate this. So we have our torsion, this times 1000 will be torsion in our torsion in Newton millimeter times 16 times 16 divided by 75 pi. So this gives the torsion, the diameter as 364756. Okay, 364756 mm. Now if I take the d value, so this I can take, so the diameter will be given as 71.45. Okay, 71.45. This gives me diameter is equal to 71.45. So this is the diameter that I am getting from this formula. Okay, so this 71 mm is 7 centimeter. It's okay, acceptable. Now there is one more part to this, so I'll just move the screen a little bit so that we can solve this properly. So, let's see. Okay. So third part we'll use the third part of the equation, that is this equation. Tau max upon T upon J is equal to G theta by L is what we are going to use. Okay. So if I use that, T upon J equal to G theta upon L. Now here, let us see theta. Theta is given as 1 degree. So this is nothing but pi by 180 radians. Okay. This is pi by 180 radians. Theta. Length is given as small l, capital L, small l we are using. Length is given as 3000 mm. 3000 mm, and G is already given. So we just substitute the values. So we can say J equal to T times L divided by T times L divided by G into theta. So we will substitute the value. The value of J is nothing but pi T raised to 4 upon 32. This should be equal to T. The value of T is 5371.5 into 1000. Length is 3000 divided by G is 0.82 into 10 to the power 5. That is G. Theta is pi by 180. Pi by 180. Now we can find the value of D here. So let's say I'll multiply a little bit. So this 180 I can take up. So D is nothing but 5371.5 times, so 10 to the power 3 and 10 to the, this 3 will give me 10 to the power 6 times 3 times 32 times 180 divided by, so this pi will come here, 0.82 times 10 to the power 5 times pi square. Okay, so this, now I can cancel this 10 to the power 5 and this 10 to the power 6, so 10 will remain. So okay, I'm sorry, this raised to 1 by 4. 1 by 4. Okay, right. Now if I pull up my calculator and solve this, it is straightforward. Okay, so this is 537.5 times 10 times 3 times 32 times 180 divided by 0.82 times pi square. So this term, now we have to find the fourth root of this. So fourth root of this will give me 103.48 mm. So that is the second answer. Diameter is 103.48. Okay, so this is the second diameter that we are getting. So we have to check this. From these two, what diameter you have to consider is this. Okay. So you can say on a round figure, take diameter is equal to 105. So this is a solution and final answer. So I hope this is clear. Again, torsion, always remember there is only two formulas that you have to remember in the torsion. This is the first formula, this is the second formula. Then you just have to know what to use when you are using this or solving this. Okay, so that's it. We will meet each other in the next video.